Looking at the second video here, compositions involving translations this time, so a second compositions video, and a couple of things to remember before we get stuck into this. Just remembering how the translations work. If we translate the point x, y by a units in the x direction and b units in the y direction, we get the scenario here where we simply just add corresponding elements onto x, y to get the image x dash, y dash. So it's quite straightforward, and the reflection in the x-axis, which we've done before, is that 2 by 2 matrix there. Okay, so let's find the rule for the transformation that will reflect x, y in the x-axis and then translate that result by -3, 4. So what we've got, we start off with a column matrix x, y, and let's reflect that now in the x-axis. So we write that transform first. So the reflect transform is 1, 0, 0, -1 if it's in the x-axis, because the y values are changed by a factor of -1, and our starting matrix x, y as a column matrix, and that comes out as x plus 0y, which is just x, and then 0x plus -1y, which comes out as just -y. And then we get this result, and then we translate it. So then we get that result, and we translate x -y. Corresponding elements are added, and we end up with x minus 3 -y plus 4, or you could say 4 minus y if you like. So remember that result, x minus 3 -y plus 4, because we're going to do something else now. We're going to switch the order around. So find the rule for the above if we swap the order, basically, if the translation takes place before the reflection, and we're going to compare it to our answer above there. So to get our image first, we've got to get what we start with, which is xy. Originally we start with point xy, and the translation was -3, 4. And so we get x minus 3, y plus 4. Step 1, that was. Then the reflection. Now remember, with such matrices, for conformability, we need to get the reflection matrix written down first. So reflecting it in the x-axis, we use that matrix multiplied by the previous result. Then we multiply through. So that's 1 times x minus 3 plus 0 times y plus 4, so that's just x minus 3. And 0 by x minus 3 plus -1 times y plus 4, which is -y minus 4. So that's a different result, and that's right, we should get a different result. Because the order at which we multiplied was different. I should say the matrices involved in the multiplication were different, i.e. that second one was that matrix there. So we obviously get a different result. It doesn't look massively different, but you can see that that sign there doesn't match that sign down there.